A new Tesla patent just went public, and it's not about some flashy new feature or a bigger battery. It's about something way more fundamental, the factory itself. And for anyone who's really watching Tesla and trying to figure out their long-term value, this is a huge deal. Why? Because it points to a massive manufacturing advantage that competitors might not even see coming. So let's start with this question. Why is it so hard to get those perfect, razor-thin panel gaps on a car? The ones that scream quality. Well, it turns out this has been a massive headache for automakers for over a century. It costs a ton of time and money, and now Tesla thinks they can solve it, not by tweaking the old way, but by completely tearing it up and starting over.
Okay, so to really get why Tesla's solution is so smart, we first have to understand why the traditional method is so flawed. It's a problem that literally stacks up against you millimeter by millimeter down the entire assembly line.
It's a thing called tolerance stack-up. Now, think about it like this. You're building with Legos, but every single brick is just a tiny bit warped. So the first piece you put down, it's off by maybe half a millimeter. No big deal, right? But then the next piece snaps onto that piece, so it inherits that first error and then adds its own tiny error. By the time you've attached the door, the fender, and the hood, all those tiny little mistakes have multiplied into a big, noticeable gap. It's a chain reaction of imperfection.
And this really shows the two totally different philosophies at play here. The old way is kind of like a relay race, where each runner passes the baton, but also passes on a tiny little mistake to the next person. But Tesla's new method, it's completely different. Every single part is positioned by looking at one and only one global point of truth. The errors are totally isolated. They never get a chance to add up.
So what is this single point of truth? It's a revolutionary idea for making cars, but it's actually an idea they borrowed from an industry where precision isn't just about looking good, it's literally a matter of life and death. At the very heart of this whole innovation is something called the global datum. The easiest way to think about it is like a master GPS coordinate system for the entire factory. So instead of a robot guessing where a door goes based on where the fender is, every single robot knows the exact, perfect, three-dimensional position for every single part. They are all quite literally reading from the same map. And this quote right here, straight from the patent, this is the core idea. Pay attention to that phrase, decouples the assembly processes. That is the magic right there. It means the robot putting on the door simply doesn't care if the car's frame is off by a hair. It completely ignores the frame and puts the door in the absolute perfect spot defined by that global datum, every single time. And if you're looking for the perfect analogy, it's this one, aerospace. Traditional car making is a bit like old-school riveting, where you build one piece off the last one. But this new method, this is how a modern jet from Boeing or Airbus is built. They use a massive precision jig that's referenced by lasers, and it defines the absolute coordinates for every single part. We're talking about a fundamental shift from relative guesswork to absolute precision. Okay, so this all sounds great in theory, but how do they actually pull it off on the factory floor? Well, the patent shows it's not just one big idea, but actually three key innovations all working together in perfect harmony. So pillar number one is the architecture itself, that universal coordinate system we just talked about. But look at that last bullet point. If you're an investor, that's the one you should circle. It eliminates the need for expensive, time-consuming inspections and adjustments at the end of the line. That's not just a quality improvement. It's about ripping a huge time and cost sink right out of the production process. The quality is baked in from the very beginning.
The second pillar is just brilliant. They actually use the adhesive as part of the solution. The system intentionally leaves a tiny, perfectly calibrated gap between the panel and the frame. Then, a structural adhesive fills that space, acting like a perfect, custom-molded gasket. It absorbs any tiny imperfection in the frame and even handles how different materials, like steel and plastic, expand and contract in the heat or cold.
But wait a minute, there's a big problem. Structural adhesives can take hours to fully cure. You can't just stop the assembly line and wait around. So the solution is something they call tacking. While the strong structural glue is still wet, a robot quickly uses either tiny little pins or a quick shot of hot melt glue to lock the part in its perfect position instantly. The car can move on down the line, and the main adhesive cures later. The line never stops. Zero bottlenecks.
All this engineering is really cool, but what does it actually mean for the business? For the bottom line? This is where it gets incredibly compelling, because it directly hits cost, speed, and quality.
65%. Let that number sink in. According to the patent, that's how many of the traditional clips, brackets, and fasteners can be completely eliminated with this system. Now think about what that really means for the business. A simpler supply chain, fewer parts to order, fewer things that can break, and just straight up lower material costs on every single car that rolls off the line.
And you can see the result of that part reduction right here. For just one component, the number of assembly steps plummets from 23 down to just 8. Fewer steps means a faster line. It directly improves what's called takt time, which is basically how many cars you can build per hour. And in the world of manufacturing, faster takt time is the absolute holy grail.
So you're probably thinking, okay, an aerospace-grade system like this has got to be crazy expensive. But get this. The patent estimates the total cost of all this advanced adhesive at just $25 per car. I mean, just let that sink in for a second. This is the ultimate goal of any industrial innovation, a system that builds a higher quality product, faster, and for less money. That is an incredibly powerful formula.
So when you put it all together, what do you really get? You get faster production. You get perfect, consistent quality every time. You get to eliminate costly manual labor. You even get a quieter car with fewer rattles. That's also easier to repair. You see, it's not just one single improvement. It's this cascade of advantages that creates a better product that's also cheaper and faster to build. And this really brings us to the big final question. As we look at innovations like this, you have to start wondering, is Tesla's most durable, long-term competitive advantage really the design of its cars? Or is it the design of the factories that build those cars, with a level of precision, speed, and cost that other automakers may struggle to match for years and years to come?